Hello, friends. Part 3 of your podcast on Section 7.1 in the AP Stats book. Just finished up doing this problem, which I didn't say earlier, but is, in fact, on page 472 in your book. Page 472, and it's example 7.3. And just to finish up, we could also have multiple probabilities. In this one, you see probability of x being less than 0.5. That's this whole area here, or greater than 0.8, and that's this area here. So if I found the two areas, which I show you here, and add them together, you get the probability for this event just being the adding from the addition rule we just learned, disjoint events, which cannot be independent. I just add the two probabilities, and that's it. All right. Now, next page, I believe it's the next page, yes, page 473, we've got something more typical to what we're going to be dealing with, all right, which is the area under a not straight curve. So you guys that have done some calculus or maybe even pre-calculus, you're up to this yet, we've got to find an area under the curve, which you could do by integrating. We're not going to have to do any of that in this class. There's no calculus in here, so don't be scared. But you've got your definition for continuous variables, and basically this just says that a continuous random variable x can take any value. Probably a good way to think of it is, if I go back to that family, if I take one family and I say, what is the probability for any number of daughters if they have 3 children? Okay, so the probability of the random variable x can be, the only values that x can take are 0, 1, 2, and 3. Those are the numbers of daughters you can have if you have 3 children. But if I was to take 25 families, count all of their kids, all right, so I did x sub 1 through x sub 25, and then took the average, all right, so if I was to sum this up and divide by n, which is 25, I'd get an average. The average number of kids in these 25 families could be any number between, and actually let's write it with the correct, it's an interval, okay? In this case, x can be an interval. It can be any number between 0 and 3, including the decimals. So, discrete, continuous, all right? Here's the difference. One random event, a bunch of random events, and I find the average, okay? So this gives me discrete, and this gives me continuous. Let's look at an example. All right, this is page 479 in your book, and it's problem 718. First thing, verify that the area under the curve is 1. This means that it is a density curve because its area is 1. It also means that it can be a probability model. So how do I verify this? Well, the area of a triangle is the base times the height divided by 2. Base here is 2. Height is 1. So that's 1. So it's verified. Check. All right. What is the probability that y is less than 1? Well, to answer any of these questions, again, you're going to find the area of the curve. So here's 1. And that looks to me like it splits it exactly in half. But to verify, it'd be the area under the curve. So 1 is the base, 1 is the height, divide by 2, and it is in fact 0.5. What is the probability that it's less than 1? Well, you should be able to figure out, same way. Let's get rid of this. All right, if I go to 0.5, that's going to be right here. And you should recognize if this is 0, and this is 1, and this is 1, that this is a 45, 90-degree triangle. I'm sure you remember that. Geometry is probably right in the front of your mind right now. So that this height has to be the same because that's a 45-degree angle. So area of a triangle is the base times the height divided by 2. So 0.25 divided by 2 is 0.125. All right, and this last bit is in your book, page 480. You should be able to put all of this in your calculator and perform simulations that verify your results. So give that a try, read the chapter, and we'll see you in class on Monday.